Hello everyone, welcome back to my channel. Today let's solve a cool logarithmic equation step by step, and at the end of this video you will not only know the answer but you will actually understand why it is so easy. So in the given, they give us logarithmic equation where they give us logarithm of x in base 2 negative logarithm of 8 in base x, that will be equal to 2. So what we are going to do, we are going to first change this logarithm of x, logarithm of 8 in base x, and change its base into 2. So what we are going to do, logarithm of 8 in base x, we are going to change it in base 2 because we cannot minus this logarithm of x of 8 in base x without changing the base. So what we are going to do here, so in base changing, that state that logarithm of 2 in base 8 over logarithm of x in base 2. This is the changing of base. So from here what we have logarithm. We are going to find this to simplify logarithm of 8 in base 2. So where we have logarithm of 2 power 3, when you take 2 power 3, that is equal to 8 over logarithm of x in base 2. Here is in base 2. So what we are going to do, here we have logarithm of 3 over logarithm of x in base 2. So where we have this act as 1, so that we have 3 over logarithm of x in base 2, so that this is the change of base from logarithm of 8 into 3 over logarithm of x in base 2. So we are going to put this where we have logarithm of 8 in base x, so that we have logarithm of x in base 2 negative 3 over logarithm of x in base 2, that will be equal to 2. So what we are going to do, we are going to put on the common denominator where we have logarithm of x in base 2 divided by 1. So we have logarithm of x in base 2 times logarithm of x in base 2, that is logarithm of x in base 2 square, negative, when we take logarithm of x in base 2 divided by logarithm in base 2, that is 1 times 3, that is 3, equal to 2. So what we are going to do here, we are going to do cross multiplication. So after that we have logarithm square of x in base 2 negative 3 equal to 2 logarithm of x in base 2. From here we are going to remove this 2 logarithm of x in base 2 in left side, so where we want to put same term together. So we have logarithm square x 2 negative 2 logarithm of x in base 2 negative 3 equal to 0. So from here what we are going to do, we are going to suppose this. Let suppose that logarithm of x in base 2 equal to y. So what we are going to do here, so when we suppose that logarithm of the x in base 2 equal to y, we are going to put this y inside this equation where we have y square negative 2y negative 3 equal to 0. We have quadratic equation. So after reaching on quadratic equation, we have y square negative 2 y negative 3 equal to 0. So what we are going to do here, we are going to use delta that is equal to b square negative 4 4ac. So what we are going to do, we are going to plug this where we have b equal to negative 2, a equal to 1, c equal to negative 3. After that, we are going to put inside this formula where we have b square, that is negative 2 square negative 4ac 1 times negative 3, so that is 4 negative 4 times negative 3, that is plus 12, which will give us 16, that is 16. So where we have square root of delta equal 16 square root, that is plus or negative 4. So after that, we are going to find y1 and y2 where we have the negative b plus or negative square root of delta over 2, that will provide our y. So well, here we have negative b, we have negative 2, that is 2 plus square root of delta, we have 2 value, that we have 4 over 2, that is equal to 6 over 2. This is a 6 over 2, that is 3. And here we have 2 negative 4 over 2, that is negative 2 over 2, that is negative 1. So that, remember, we suppose that y equal to logarithm of x in base 2. So what we are going to do here, from here we are going to put logarithm of x in base 2 equal to first y, that is 3. So in order to get this x, we power this number to here. No, in order to get x, what we are going to do, we are going to log of x in base 2 equal to 3 log, we multiply the same base with this, that is logarithm of 2 in base 2, this act as 1. So what we are going to do, logarithm of x in base 2 equal to this, move here. So where we have logarithm according to the property of logarithm, that is 2 power 3 in base 2. So because here we have the same logarithm cancel each other, then we have x equal to 2 power 8, 2 power 3 equal to 8. So the first x1 equal to 8. So what we are going to do, we are going to, for y2 equal to negative 1. So what we are going to do, we are going to put logarithm of x in base 2 equal to -1. So what we are going to do, we are going to do the same as in first y. So where we have -1 times logarithm of 2 in base 2. So after that we are going to have logarithm of x in base 2 equal to this one is going to power here because according to the logarithmic property. So we'll have logarithm of 2 power -1 over 2. So this logarithm and this cancel each other, where we have x2 equal to 2 power -1, that is give us 1 over 2. So this is the value of our x. So when we want to prove, so we can put this value of x back to the equation. So where we have our equation is logarithm of x in base 2 negative logarithm of 8 in base x equal to 2. So we are going to put x for the value. So where we get first x is 8. So where we have logarithm of 8 in base 2 negative logarithm of 8 in base x, where x is 8 equal to 2. Let's see. So here what we have, so here we have logarithm of 8 to negative logarithm of 8, that is 1. Yes, -1 equal to 2. So here we have logarithm of 2 power 3 in base 2, where we have 3 -1 equal to 2. Then proved. Yes, that is proved. So the value of x equal to 8x1 and x2 equal to 1 over 2. That is our final answer. Final answer is x1 equal to 8 and x2 equal to 1 over 2. So that is our final answer. So thank you very much and see you in the next video. And if this video helps you, please share to your colleagues and hit subscribe button so that we can be together in the next video. Thank you so much.